Good afternoon, everyone. I think today we have to start a new chapter. Am I right? After completing motion in a straight line, yes. We have to start the new chapter. Okay. Right. Coming to here, the new part. That is, till now we discussed about motion in only one direction. Yeah, good. Motion in one direction. Right? That is motion in a straight line. Now we are entering into motion in a plane. Right? This is motion in a plane. Yes, this is the chapter name. Okay, means here we are going to discuss the simultaneous motion in two directions. Simultaneous motion in two directions means, suppose if you ask the velocity of a body until now, a body is projected vertically upwards with an initial velocity of say some 20 meters per second run. Just I am giving the velocity in one direction. Okay, but in this class, from today onwards, we have to take the velocities in two directions simultaneously. Okay, that one we are going to discuss, Nana. For that, here to understand, suppose if I say like this, this is from the ground level, Nana. First, you assume one coordinate system like this, x-axis and y-axis, both the axes. Actually, according to textbook numbers, I think this may be the 1, 2, 3, 4th chapter, right? But in continuation, this is the second chapter. In this chapter only, already we completed the vectors part. Vectors part is actually the part of this chapter, motion in a plane. Yeah, good. Okay. In this means already we went through some part of this chapter, that is vectors. Okay, remaining chapter today we are starting. Okay, going to complete the remaining part of motion in a plane. Right. Suppose if I take the xy coordinate axis like this, and I am saying that suppose one body is projected, look at here, not vertically upwards. Okay, that is again becoming one direction. Not exactly along x-axis. Again, this is one particular direction. But in between these two, making some angle like this. Okay. How much is that angle, sir? I don't know. Let it be theta. Okay. How much velocity you gave, sir? Yeah. Good afternoon, Nana. Okay. No problem. Just now only I started the class. Okay, nothing to worry. So here, if you see, okay, right. If you see here, Taruni, okay. This velocity projected from the point, say O, okay. With what velocity you projected, sir? This is the initial velocity I'm giving here at O. That's why, as usual, I represent with the same letter, initial velocity U. Okay, good. That initial velocity, if you see here, neither along x-axis nor along y-axis. So how to say this initial velocity in better way, that is in both the directions? Okay, for that you have to recollect some part of vectors. I think you know how to resolve this initial velocity into two components. Anyone remember, Nana, that resolving of a vector into two components? If you remember, type the two values. What will be the value along x-axis and what will be the value along y-axis? Cos theta. Yes, very good. One is u cos theta and u sin theta. Very good, very good. And here, who will be along x-axis? Is it good? This is better. U cos theta along x-axis. Very good. Means adjacent side, right? So this will be u cos theta and it will be u sin theta along y-axis. Very good. Okay, that in vector form. Okay, I just assume this is along x-axis. The initial velocity u along x-axis, I take it as ux. Ux is equals to u cos theta. And the initial velocity along y-axis. Initial velocity u along y-axis, uy, is equals to u sin theta. Okay, that try to represent in vector form. Vector form means u bar. What I am asking, u bar equals to, I think all of you remembered, along x-axis I have ux. Since it is along x-axis, I cap. Am I right, Nana? Is it correct? Along x-axis, I cap. Yes, good, good, good. Plus along y-axis. Yes, along y-axis. This is uy. Good. J cap. Right, good. This is j cap. This is the way how to represent a vector. Initial velocity. Now you observe here, it has the velocities in two directions. Okay, two directions. So it is not motion in a straight line. Two directions, 2D. In mathematics, 2D is a plane. That's why it is motion in a plane. Okay. Then what will be its motion? That's what we are seeing here. Okay. Once projected into air, I think that body will be affected by some gravity. What is that gravity? Acceleration due to whom? Okay, I think you did not follow what I am asking. Means after projecting, this body experiences an acceleration. Okay, that acceleration, can I say after projecting, since it is in air, its acceleration will be the acceleration due to only gravity. Yes. Uh, is it along? Okay, okay, okay. 10 meter per second square. Very good. That I accept now, Mr. Amok. Acceleration is equals to g. Yes. But will you say that's okay, okay, okay. No problem, Nana. And here that acceleration due to gravity is in what direction? Gravity tries to pull it downwards or upwards? Down. So this is the acceleration due to gravity downwards. Very good. Downwards. Downwards means here you say downwards is coming along negative y-axis or x-axis? Negative y. Very good. That's why in vector form, can I write it as a bar equals to g into downward, opposite direction to negative, positive y-axis. That is negative y-axis. Negative y-axis means, can I write a minus I cap or j cap? Good. Minus j cap. Very good. This is the acceleration. Okay. So it is experiencing a acceleration in only one direction. What is that direction? Y or X? Y. Very good, very good. So can I write that one more clearly as A bar is equals to 0 I cap minus G J cap. Will you accept, Nana? Yes, yes, good. So here also that acceleration I represented in 2D, but acceleration is there only in one direction. That is along y-axis. That too negative y-axis. And initial velocity, it has the velocity in two directions, along x-axis, along y-axis. Okay, good. That more clearly you write here, Nana. Means by distinguishing x direction and here y direction. Distinguish. Okay, distinguish the two like this. Okay, this is x direction and that is y direction. Okay, I am taking like this, like forming a table. Okay, both the directions. Okay, Nana? Now it is the time to say. Okay, you have to tell one by one. I ask and you try to say. What is the initial velocity along x-axis? Along x-axis, what is the initial velocity? Quickly. U cos theta. Very good. So initial velocity is u cos theta. Very good, very good. This is along x-axis. So ux is equals to u cos theta. Very good. And I think right. Along y-axis, it is u sine theta. Right, good. And in the same way, tell the accelerations, Nana. Acceleration along x-axis, 0. Very good, very good. Along x-axis, it is 0. And along y-axis, you see here, minus gk cap, minus g. Very good. Along x-axis 0 and along y-axis, it is minus g. Very good, no problem. Okay, right. Means you are taking upward as positive and downward as negative, minus g. Very good. Now I am asking, suppose while going here, after certain time, it came to here, follows which path, I don't know. Suppose comes to here, after certain time. Comes to here means in mathematics, if I ask, Arenana, what are the coordinates of this point? Sir, let it be x comma y, sir. Usually what we say. Okay, its coordinates. Means, can I say in my physics, along x-axis till here, its displacement is x, and along y-axis, its displacement is y. Can I say like that, Nana? If the coordinates are x comma y after certain time. Yes, very good, very good. So after certain time, okay, t, after certain time, the displacement along x-axis, let it be, assuming it as x, and let it be y along y-axis. Yeah, y meters, x meters. Okay, right, good. Now look at here. Which equation is to be used to find out the x value? Yes, u, a, t. First or second or third or fourth equation? Yes, second equation. S is equals to ut plus half at square. Very good, very good. So in both the directions, I am using S is equals to ut plus half at square. Right, good. Okay, even here also using S is equals to ut plus half at square in both the directions. How much I get? Right. How much I get here? Good. X is equals to here along x-axis. x is equals to u is u cos theta into t plus half a t square. No need to substitute. Why? Because a is 0. A is 0 means this whole thing, right, this whole thing becomes 0. Good afternoon, master. Too late today. Okay. Here also shortcut. Sorry. Okay. Mr. iPhone. SORRY became SOSRY. Okay. Good. X is equals to u cos theta into t. Mr. Bharat also came late today. And here second equation you will get Nana. Y. Good. Y is equals to, that implies second one. U is u sine theta into t plus half a. Shravan. Okay. A is minus g into t square. New chapter Nana. Okay. This is x is equals to u cos theta into t. This is y is equal to, substituting all the values, u sine theta into t minus half gt square. Okay. Observe here, in both I am finding out one common term t. No problem, no problem. This is easy only, Nana. You can understand. Okay. Just t is equals to, from this equation, I can write x by u cos theta. Okay. And take it as first equation now. Okay. Take it as first equation. And this one, try to substitute. Yes. Vectors, Nana. It is based on vectors part. This initial velocity resolved into two components. And in the two directions, what are these displacements? I am going to find out. Okay. When a body is projected here at an angle theta into air. Yes. So here that t I am going to substitute in this second equation. Okay. Take it as second equation. Right. Then you can remove t and you can interlate y and x here, Nana, from the two equations. Okay. That I am going to do here. That implies what I am going to write. Very good. I think already substituted. Nice. Y is equals to, that is correct only, u sine u, I think you won't get there, Nana, in the first part. U sine theta into t is x by u cos theta. I am substituting here. Okay. So Manikanta, here I think you get cancelled. Okay. So minus of, half g. From the beginning only I explained, now only kada Nana. Half g t square. T square is x square by u square cos square theta. Okay. So here, how much you get there? Y is equals to sine theta by cos theta. That is tan theta into x. Okay. Minus half g into x square by this whole thing, u square cos square theta. Okay. This equation you have to remember for the numericals. You must buttify the relation between the displacement along y-axis and the displacement along x-axis. After resolving u into two components like u cos theta and u sin theta. Okay. So is it clear, Nana? Or any doubt in the middle? Okay. No doubts. Right. Good. Right. So here, this is the story, Nana. So what we did here, Mr. iPhone, This initial velocity, resolved it into two components. Okay, like u cos theta and u sin theta. After projecting, what is the acceleration in air checked and its direction. Okay, since it is downwards along negative y-axis minus j cap vector form that we wrote, and that acceleration in two directions, velocities in two directions, we wrote here separately. Okay, along x-axis, along y-axis. What are the displacements? We copy. Okay, right. So no doubt, sure. Good. Then here, Nana, this type of equation, if I go to next page, if you see here, yeah, formula derivation, and it is important for IP also. This is actually 4 marks question, Nana. Okay, 4 marks means generally we say short answer questions, short answer question. Right, derivation is important for IP. For objective, this last formula and these two formulae, whatever I highlighted in the boxes, all the three formulae are important for objective. Okay, na? Right. So if you see this equation on the next page, here for a body after projecting, tan theta is constant. So tan theta, I am taking it as some constant A. Okay, and number 2, here half constant, g 10 meter per second square constant, u initial velocity constant, theta angle with which you projected, angle of projection constant. So everything here constant. That everything, what are there? Look at half g by u square cos square theta. This whole thing is a constant. Let it be b. It is okay. That implies the equation which is highlighted in the blue box here can be written as tan theta assumed as a, and this whole thing is assumed as b. So I am getting y is equals to ax minus bx square. Okay, this one also you have to remember for objectives. Okay, na? Right. So the displacement along x-axis, the displacement along y-axis, and the relation between y and x in the big form and in the short form. Okay, Nana? Half gx, ayo, half g by u square cos square theta, I assumed it as b, Nana. Means you have to understand that here I will highlight in another color, Nana, you can understand. This whole part is b. This whole part is a. Okay, got it? Right. So y is equal to ax minus this whole thing is b x square. Okay, b x square, Nana, x square, that is not c. Okay, a into this is x. Okay, right. This is the equation, Nana. This equation in mathematics actually represents the above equation. When you go and check in mathematics, the above equation represents a parabola in mathematics. Okay, fine, Nana. And which type of parabola? If you ask, that parabola here is saying in mathematics, if you get the equation like this, that type of parabola is like here symmetric to x-axis, it will be like this. Okay, it is the parabola whose equation in mathematics is, yeah, you can watch there. That is your wish. Okay, yeah, here, no problem. Y is equals to ax minus bx square. Okay, so here if I ask in my physics, Aranana, if a body is projected at an angle theta with the horizontal, then what is the path followed, Ra? Then what do you say? We already proved here. What is the path followed? What is this path, Nana? Path, I am asking. Path means the shape. It is for, right, parabola, right, correct. Okay, so here the path followed. Now if I draw, I will get a parabola like this. This is the shape of parabola. Okay, Nana? It is the story. Okay, so here remember all these equations, Nana, better related to these equations. Now only we try to get some problems, otherwise we may forget. Okay, so can I give one or two examples related to them? Yes, that's better. So take example 1 so that we can recollect the formula even. What are the formula here? Along x-axis, how to find? Along y-axis, how to find? How to find the yx relation? And how to find the a value? How to find the b value? Like everything you can find here. Okay. Look at my example, Nana. What I am saying. A body is projected. Projected means thrown. Okay, is projected how? At an angle of 30 degrees with whom? With x-axis. Look at Nana, here every time I'm saying theta less than 90 degrees. Okay, angle of projection is less than 90 degrees. That is 30, 60 like Nana. Okay, with x-axis, right? Comma, with an initial velocity with an initial velocity of 20 meters per second. Okay. Now, here I am asking, find number 1. The displacement along x and y axis, okay, in a time of 1 second. Oh, 20 by root 3, 10 root 3. Okay. Right, good. 10 root 3. That is equals to x. Right. Good, I will check it. So I'm taking here the solution. Along x-axis means u cos theta into t, where the information body is projected at an angle of 30 degrees with x-axis only. So theta is equals to 30 degrees. Yeah, maybe correct. Yeah, in the meanwhile, try to find out y also, Nana. Y is 5. Oh, okay, good. U is equals to initial velocity 20. And as usual, I take g is equals to 10 meter per second square. And time is equals to 1 second. Oh, 5. Okay. Yes, we will check it. So x is equals to u 20 cos 30 root 3 by 2 into t1. Yeah, exactly. This is 10 root 3. Accepted, Nana. Your answer is correct. Y is 10 or 5? Okay, I will check. Y is equals to u sine theta into t minus half gt square. Okay, 10 root 3 x value is correct, Nana. Y. U is 20, sine 30. Sine 30 is half into t is 1 minus half. G is 10. T square is 1. 1 square is 1. I think it is 5. Yeah, 10 root 3 and 5. Yes, correct. Y is equals to 10 minus 2 5s. Okay, it is 5 correct. Yeah. 10 minus 5, that is equals to 5 meters. Okay. So x is equals to 10 root 3 and y is equals to 5 meters. Good. So here already two equations we recollected. One is u sine theta into t minus half gt square. Other is x is equals to u cos theta into t. Okay. And now the second question. Right? Find the total displacement in 1 second. This one I will see how many will get the answer. Total displacement, Ra. Suppose along x-axis this is 3 meters. Along y-axis suppose this is 4 meters. What do you say the displacement, Mr. Amok? Suppose it is 3 along x-axis, 4 along y-axis. Now I think you got the correct answer. 20 root 2, na? 20 root 2, na? Okay. Yeah. Here this is 5. Okay. Right. In the same way here you have to calculate, Nana. How you got the displacement as 5? Like root of x square plus y square. And that is equals to 5. You are saying 3 square plus 4 square. In the same way, you have to find out the total displacement. I think Lakshmi Gayatri, your answer is wrong, Nana. Okay, once check again. Yes, wrong. Yeah, correct. So second question, answer if you write here, total displacement is equals to root of x square plus y square. Yeah, good. You can remember it as another formula. Total displacement, root of x square plus y square. Okay. That implies S is equals to total displacement root of x square 10 root 3 whole square plus that is I think 5 square, right? 10 root 3 whole square means this is 300 plus that is 25. You are getting this is 325. Okay. So here this is root of 25 into I think 13. Okay. Yeah. That is 5 root 13. 5 root 13 meters. Yeah, good. Right. This is the total displacement. Right. Now here third question, if I ask represent the displacement in vector form. Displacement in vector form. Displacement in vector form. Yeah, very good. 10 root 3 I cap means x I cap. Okay, plus yj cap. Very good, very good. You are right now. Yes, correct. Okay, this is the displacement. And here you can represent this is xi cap, and here vectors chapter this is yj cap. Oh, yj cap. Okay, very good. Yes, accepted. Yes. So here the displacement extra formula I am writing. S bar is equals to x I cap plus yj cap in vector form. Yes, after a time t. Okay, this is one more extra formula. And here its displacement already we calculated there. Mod s bar displacement is equals to root of. Here you know in vectors this is x square plus y square. Okay, throughout the chapter we use the vectors methods, Nana. So better try to recollect as quickly as possible this vectors part. Okay, throughout the chapter we use vectors. Okay, if you forget, then better you try to recollect as quickly as possible. Good. So third question answer. Okay, right. Already you said there answer. That one I am writing here. Third one. S bar is equals to x I cap plus y j cap. That is equals to 10 root 3 I cap plus 5 j cap. Very good. Okay, right. First part you did. Okay, with the small hiccups, finally you found the answers. Okay, now come to the second question, Nana. Yes, good. Right? In this question, I am saying, um, okay, y is the path followed by, not of course Gandhi, a body projected okay at an angle with the horizontal. See, that one with simple word I'm saying obliquely. Okay, obliquely means at an angle theta. Projected obliquely is represented as y is equals to root 3x minus 5x square by 12. Okay, represented like this. Right? Now the question, number one. Oh, very good, very good. And take g is equals, okay, no problem. Here, find The angle of projection, already Amoga, yeah. Even you also put the answer. 30, yeah. Tanisha, angle of projection, 60, correct. Angle of projection and the initial velocity. Yeah, 60 is correct. And the second one is initial velocity. Okay, very good. In the meanwhile, I also complete the first part. What you got the answer? 60. All of you got almost. Given that y is equals to root 3x minus 5x square. Oh, is it correct? Okay. Maybe correct, I think. I will check now. By 12. Okay, it is exactly in the form of what, Nana? Ax minus bx square. Okay, where a and b, we have to remember the two things. Okay, this is in the form of, that implies y is equals to ax minus bx square. That implies, by comparing, I am getting a is equals to root 3 and b is equals to 5 by 12. A formula is tan theta. Tan theta is equals to root 3. So obviously all of you know, tan 60 is root 3. So theta is equals to 60 degrees. This part all of you put the answer also there. Yeah, many typed. Okay. So this was very easy. Leave it. Come to the second part. B. This one you have to remember. Why? Because big equation of G by u square cos square theta is given as 5 by 12. Okay. Half G is exactly fine, Anna, by taking G is equals to 10. If you substitute G is equal to 10, you will get here 2 5 5 by u square cos square theta equals to, I got 5 by 12. Yeah. Okay, maybe correct. That implies, by comparing 5 cancel, u square cos square theta equals to, I am getting 12. Okay, that implies u square cos square theta is 16, Anna. Cos square 60 is equals to 12. Yeah. Why others not put the answer here? Now when I come to last step, you put the answers. Okay, smart students. Sabha. Okay, cos square 60. Cos 60 is half. Cos square 16 is 1 by 4. Okay, right. Not you, Nana. You and Amog only put the answers. Rest of the students simply they are watching. Okay. Why? Because you both put privately. So, Papam, they are unable to see the answers. Just kidding. Okay. Don't take it serious. Right. This implies u square is equals to not 2 root 12, Nana. 2 root 12, of course, that is also correct. Still, you can simplify. Okay. Right. 12 fours are 48. That implies u is equals to root 48. This is 16. Threes are 48. 16. Root 16 is 4. 4 root 3. Okay. 2 root 12 also correct, Nana, Ishan. Again, that 12, if you write it as 4 into 3, you will get the same answer. Okay, that is 4 root. Right, good. This is, yeah, right. 4 root 3 meter per second. Right, good. So here I think we once recollected all the formulae what we discussed today. Initial velocity we recollected, and displacement, both vector form, magnitude we recollected. Both the equations here we recollected. This part also we recollected. A is how much, B is how much. Okay, I think we covered everything. from here what we discussed. Okay. So we got some idea about the displacements part. Okay. In that projectile motion, yes, yes. What are the displacement? One more, do you want? Okay. After completing few more concepts, I will give one assignment, Nana. In that you try to solve. Okay. Good, good, good. Right, right. Then here I am asking, say the body projected from ground level, okay, like this, in a plane. In a plane means every time we have to draw two coordinate axes. In a plane, okay, thank you. In a plane, and here a body is projected at some angle like this. Okay. Of course, it follows the path. All of you know which path it follows. Okay, parabola like this. Okay. Now the question is, if its initial velocity is u and angle of projection is theta. Okay. And here again, I'm not asking what are the initial velocities along x-axis and y-axis. Both you know already in the first part. Along x-axis that is u cos theta, along y-axis that is u sin theta if you resolve. So that I am not asking. And acceleration also I am not asking. Yes, you know it. 0 I cap minus gj cap. Okay. So those two directly I am copying here. Nana initial velocity u bar equals to, okay, simply without explaining, straight away I am writing like this. Okay, I think even you also don't ask anything from it. You know it. And here acceleration again without explaining, I'm writing like this. Yeah, I think you understood. And again here I am drawing one table. Okay, yes. This is x along x-axis. And this is along y-axis. See here what I am going to find out. Okay, first distinguish the two. Right. Okay, both are distinguished. Clear. Okay, and as usual, along x-axis and y-axis, I am writing the initial velocities. Okay, simply you also watch what I am writing. Why? Because you know it. No need to shout, no need to respond. Yes. Thank you. I will see. And acceleration. No need to respond, just watch it. You know it. Okay. Again, I am asking after certain time. Okay. Yeah, okay. Sure, sure, I will watch. After certain time, t. Okay. Again, don't shout. Here, I'm not asking that the coordinates that you know x comma y. Okay. But I'm asking at this point, what are the components of final velocities along x-axis and along y-axis? How much? This time I'm focusing on velocities, not displacements. Okay, right. Sure, sure. Which is u cos theta, Nana? Along x or y? First one. Right, good, good. Means I think you are using first equation. Okay, like v is equals to u plus at. Yeah, good, good, good. So both sides I'm using, yeah, good. Correct only now. Using V is equals to U plus AT here and there. Good. V along x-axis, Vx, yeah, that is equals to U is. Who opened the video here? Vx is U cos theta plus A is 0. That's why no need to write this term. Simply U cos theta over along x-axis. And along y-axis, Vy equals to, here U sine theta. Yes, yes, yes. Oh, almost all of you got. Yes, yes. U sine theta plus A is minus G into T. Very good. So this time I got the two velocities here, Nana. Along x-axis, one equation you have to remember to solve the numericals. And along y-axis, U sine theta minus ct. You have to remember to solve the numericals again. Okay? Means at this point you got one component along x-axis. Yeah, you can use v square minus u square is equal to 2s, but I did not give the displacements along x-axis and y-axis here. Okay, if I give, you can use Mr. Shan. Okay, I gave what time. That's why I went to first equation instead of third equation. So is it clear? No, yes, you know, but what the information he gave there, according to the information, we have to solve. Okay, if I give here x is equals to blah, 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 then you use the equation v square minus u square is equal to s. Right, good. Okay, next I will ask that one also, Nana, so that you can say the answer. Okay, good. Then here, yeah, good, correct only. This is along y-axis, what I got here. Okay, this is one component which is Vy along y-axis, and this is Vx along x-axis. Okay, look at here, the initial velocity and the final velocity along x-axis are equal. Reason you know, why? Because there is no acceleration along x-axis. No acceleration means the body moves with uniform velocity. All of you know that along x-axis. So along x-axis, everywhere, not only here, everywhere if I ask along x-axis only, no need to solve every time. Directly you can say that is u cos theta. Understood this point, Nana? All of you? Yes. So along x-axis at every point, initial and final. Yes, at every point it is same. Okay. That conclusion I am writing here first. Okay. Yes, yes. After projecting, okay, the component of velocity along x-axis, yes, along x-axis remains same at all points because there is no acceleration along x-axis. Okay, that implies velocity along x-axis, in simple words we can say, is equals to u cos theta always. Is my conclusion correct, Nana? Finally, what I concluded, velocity along x-axis is u cos theta always. Yes, correct. This is one important point that you have to remember. Okay. And number two, look at here, Vy. This is initial is u sine theta. Final is u sine theta minus something. You are subtracting. Subtracting means gradually its velocity decreases. Deceleration decreases. Decreases means surely at some one point it should get the velocity 0. Am I right? Yes. Okay. That point where Vy becomes 0 is called as highest point. That's what I'm saying. Okay. Understood, Nana? Where this Vy becomes 0, that point we are calling it as highest point. Is my conclusion correct? Yes, yes, very good. So here, don't say this is always same at all points. We can't conclude anything from here. But from this point, we can conclude. Okay. Yes, the vertical component, the component of velocity. Component of velocity along y-axis. Of course, by seeing this also, you can say that is minus g. Minus g means it decelerates. Surely at one point, the velocity should turn to 0. So here the velocity along y-axis, okay, decreases and becomes 0 at the highest point. Highest point. Okay. So if I see at the highest point, suppose this is the highest point. Okay. At that highest point, if I ask, what are the velocities, Ranana? Sir, surely one thing I can say, sir, Vy 0, sir. Okay. What about Vx, Ra? That I don't know, sir. Really, you don't know the component along x-axis? Okay. Say promise exactly at 4 o'clock. Don't say the wrong answers. Now it is exact 4. Yes, that is u cos theta. Yes, at the highest point, it has some velocity. This is u cos theta, but vertical component is 0. So here Vy equals to 0, but still Vx is there, that is equals to u cos theta. Okay, highest point. That implies at the highest point, okay, Vx is equals to u cos theta and Vy equals to 0. Okay. And now quickly try to complete this concept, Nana. Why? Because we already crossed 4. Okay. So here, last but not least, come to here. Will you represent? No, 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 no. I will try to complete it. Okay. Here, see. It's vector form. Okay. Vector form of velocity after a time t. After a time t is v bar is equals to, Amok put the answer also. Yeah, I want to rewind. Sure. I will rewind all the pages now. Don't worry. Okay, along x-axis is u cos theta, that is Vx. Okay, Vx I cap plus along y-axis, that is Vy. See the value, Nana. U sin theta minus gt. Okay, that expansion letter I write. Okay, this is Vy j cap. Okay, this one you wrote like Mr. Amok. Vx is u cos theta into I cap plus Vy is u sin theta minus gt into j cap. Okay, minus gt into j cap. Not like that. Okay, this is V bar. And its magnitude, if I ask, mod V bar. Okay, that is simple. One step you can say. Mod V bar is equals to root of vectors, you know how to find the magnitude. Yeah, simple. Yeah, don't substitute the value. Simple, you can say Vx square plus Vy square. Okay, there later we try to substitute the values if we require that in numericals. Okay, Nana? Right. So here for today, I stop the class and try to remember these formulae. Why? Because tomorrow we have to solve the numericals related to velocity. Okay, Nana? Good. Yes. Coming to one by one pages, Nana. This is the first page. If you want to take yes, you can take. Is it over? Right. Next, second one. Okay. Thank you, Nana. Yes. And this is third one. Okay. Thank you. And this is fourth one. Thank you, Nana. Right. And this is fifth one. Okay. Bye, Nana. Bye, everyone. Yes.